Okay, what I want to go over are umasks. And what a umask is, notice right now I'm in root junk. And if I create files, touch file 1, file 2, well, file 2, file 3, make directory dir1, 2, I did it again, 2, 3. Notice that files are all created with a certain set of rights that are there to begin with. See, they're all just alike. And directories are the same way. They're all just alike. So what determines what your rights are? What if you're using a system and you say, you know, I never want a read permission there to begin with? Well, the way it's set is with a command called umask, user mask. Doesn't look very useful right now. It just put out 0022. But let's take a look and see how this is actually working. User mask. The way that umask works is you have to know to begin with that files by default, I'm doing this again, are created with rights of 666, and directories come up with 777. Now that's the way that the very guts, I'm not sure if it's the actual kernel that does that, but Linux itself, when it creates files, it wants a mask, or it wants them to be created with rights of 666, and it wants directories with 777. Now obviously that's not 666 and 777. That's 755 for directories. Do we see how we get 755? There's 7, and then 4 and 1 make 5, so 755. And files are different. There's 644. 6, 4, and 4. Okay. What the mask does for us is you have to remember that it is a mask. So let's draw some stuff out. Let's say I am creating a file. File 1. Now, as I said, it's wanting to be created 666. So rw-rw-rw-. That's 666, right? Okay, what the mask is doing, and currently my mask is 022. Ignore that first 0. 022. So if I put in 0, 2, 2, and use that as a mask. A mask means, okay, if there's nothing here, fall straight on through. If there's something there, block it. If there's nothing up here to fall through, you don't add anything. It's a mask. So this is the umask. So what your effective rights wind up being is R minus nothing winds up being an R. The W minus nothing winds up being a W, and then nothing from nothing leaves nothing. The R falls through. The W is blocked. And then nothing and nothing. The R falls through. The W is blocked again. And then nothing. That's your effective rights. So that's why this is what our file should be coming out as right now. And sure enough, they're coming out as 644. That's where the 644 comes from. All right, let's take a look at a directory. If I can find my screen again, where did it go? That ain't it. There it is. A directory. Now, let's see. dir1 is going to come up 7, 7, 7. And again, the mask, you use the same mask, umask, for files and directories. That seems a little bit odd, but that's how it works. You use the same mask is in place whether you're creating files or directories. So the umask is still 0, 2, 2. That ain't 2. That's 2. So the first one that falls through is going to be RWX. It all falls through. The next one, the R falls through, the W gets blocked, and the X comes through. And the last one, the R and the X fall through. So that winds up being, that's your effective writes. Of 755. And that is why these writes are the way they are. So let's monkey with it. First off, let's try to predict what's going to happen. If we change our umask, let's change it to 200. How is that going to affect files? While I'm scratching this out, you scratch it out too. What's the effective writes going to be on files with a umask of 200? All right, just scribble it down real quick. Files we know by default are they don't have the X. And that kind of makes sense. Would it make sense for every file that you create to automatically be executable? No, executables are created, they're compiled. So it makes sense for that to be turned off. And our umask is just going to be this 0 and 0. So that means the only thing that's going to be blocked is that read. That write's going to be blocked. Does that look like it makes sense? That doesn't make sense? Oh yeah, it's not practical. It should make some logic, but would it be useful? No, it's goofy that you would want others and anybody in the world to be able to write, but not the owner of the file. But let's say umask 200, that's a 2, that's a 0, that's a 0, 6, 6, 6. That falls, that falls. The only thing that's blocked is that. Okay, how about directories? They come up 777. And if we put in our 200, the effective writes are going to be what? R nothing X RWX RWX. Alright, so that's kind of goofy, but let's see if our goofiness has actually worked. Changing umask is pretty straightforward. 200. To print it out, you just say umask. You're going to have one umask effective at a time. Now you can monkey with it, and then every time you monkey with it, all the files that are created after that are affected by that umask. And we can say that too. We can say ls-l. Nothing changed in your file system in the stuff that's already been created. That didn't do anything to that. Question? It doesn't add it. That's the one thing that we didn't really look at. If your original, let's say, was 666 for a file, RW dash RW dash RW dash. Sorry about my writing. The tablet makes it worse than it already is. And our mask was dun dun x dun dun x dun dun x. What would that umask be? 111. What she was asking was, would this add an X when there was nothing there above it? And no, it wouldn't. Like a Halloween mask doesn't add anything, it just cuts holes where stuff can pass through. So this would wind up, what would the effective rights be on this? Yeah, we wouldn't change it at all in this instance. Well, heck, we've done it. Let's do a directory. A directory would be rwx, 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 and it only blocks. It's a mask. That's just going to block execute from everything. That would actually be handy if you wanted to never create anything that was executable, but everything else was writable. RW bump, RW bump, RW boom. That's kind of cool. It makes your files and your directories come out just the same. Okay, let's back up and do the one that we were originally planning, which was 200, and that's what they should look like. And again, just to check my umask, 22. So now, touch file 10, 11, make directory dir 10, 11. Those stand out pretty good, don't they? The directories are executable and writable. The only thing missing out of the directories is the write field. Directory. Have I lost my mind? Yeah, the write for the owner, the user. So yeah, that did come out how we expected. And files should be 466. Probably a better way to express it. Files 10 and 11 have come out 466. All right, get rid of all of it. Nice and clean. Let's change the umask to 111. 111. File 1, 2, 3. Are they just the same? It kind of threw you off for a second. The only difference is the D. The D has to be there because these are directories. How much space does a directory take up by default? It takes up 4K just for creating a directory. So if you got bored sometime, you could fill up your hard drive just with making directories with nothing in them. A good exercise in futility. And again, what is ls-lh? Human readable, so that I can actually see that it's 4K. Alright, so what we need now is some kind of problem. What would I do if I wanted my files? Let me pause this for a second. Well, okay, what kind of umask would I use if I wanted my files all to come out? Let's see. File 1 chmod 444 file 1. I want all my files by default to come out like that. Every time I want to create a file, I want it to come out read, read, read. So real quick, think about it and tell me what you would set your umask to accomplish that. 222 and 333 would both accomplish it. Now, what would really make me fine-tune my question would be, what if I want directories to be like that too? I want files and directories to come out read, read, read. Then it has to be 333. And let's work through the logic on that real quick. A file by default is going to be RW nothing, RW nothing, RW nothing. And if we set it to 333, that's going to be R is going to pass, everything's blocked. R is going to pass, the rest is blocked. R is going to pass, the rest is blocked. And the same with the directory, that is wide open by default. R nothing nothing, R nothing nothing, R nothing nothing. And that is 4, 4, 4, and that is 4, 4, 4. Now what we had said is, would 222 up here worked? Yeah, it would, because there's nothing in that space, or that space. So the reason that we had to go with 333 was to catch the directories as well. Alright, real quick, let's plug that in, make sure it works. umask 333. 333. Touch file 2. Yep. The only difference is the little D sitting right there. Okay, so the only thing that's still kind of sticking me in the head is, the only thing that's sticking in my head is, if there want to be created 666 and 777, where did it get set to 022? By default, you'd think it would be set to 000. Well, if you go digging through your files, and let me look for it real quick before I put it on the video. Here we go. You have lots of startup files. When you log in, there's about a half a dozen files that run to set up your environment. And one of them is in the Etsy directory, and it's called bash rc. And what we're seeing in it, every time that it runs, you've got a little question. You've got a little if the user ID is greater than 99, then set it to 002. Otherwise, set it to 022. Who was I? I'm root. Got the pound prompt. Pound prompt. So my user ID is 0. Root's user ID is 0, so that my user ID is less than 99, so my umask was set to 022. So that means if I'm over 99, or a regular user's ID start off around 500 normally. So let's monkey with that. SU space dash. Is Steven still a user on here? Yes, he is. What do you know? My umask is 0002. So root's umask is a little bit different than a regular user's umask. Now, a lot of that's over your head. I don't expect you to know how to go find Etsy or Etsy bash rc or that kind of stuff, but that should at least show you that the masks are set up in the configuration files. All right, let me stop it here just a second.